Perhaps now it's time to start thinking about how to add a loop to the code in order to plot many weeks of data instead of just one. Ultimately, we've got our code set up so that what we want to repeat for each week is going to start somewhere around here. Ultimately, we're not going to have week start just at one value. This value is going to change each time through the loop. Then we can calculate our week end, and we can run all of this code up until the device is turned off for each week of data instead of just for the first week. So first of all, ultimately, we need to change our code so that our week start isn't set to a particular number. And it might be helpful if we just set a start time up here before the loop that defines the beginning time for the entire plot as opposed to just 1 week. And we're probably going to want to start with something like the minimum time, just like we did for week start. And then we can just change this, the week start, to just be the start time. And right now, that's not going to change how our code works, but now we're set up to alter this so that it varies each time through the loop. Ultimately, perhaps the algorithm could be we want to add on however many times we've been through the loop so far, which for the first time will be 0, multiplied by the number of seconds in a week, which we've already calculated as 604,800. And then ultimately, if we replace this 0 with a counter that increments each time through the loop, that way we're starting on a new week each time through the loop and plotting that week with the rest of the code. So that's our strategy for how we're going to build the loop. Of course, right now, this math is just going to be the same thing as start time, but I'm going to leave this here just to keep track of the logic that we're thinking about. And I can go back up here and say, what is my start time? Well, it might be better and cleaner in each graph if it starts on midnight of a given day instead of just at some arbitrary time during the day. It might be easier to do our quality assurance if we could just see a clean break in the middle of the night for each week that we're looking at. So we can do that with the trunc function. The trunc function, and specifically if we call trunc on this, it's going to use the trunc POSIX-T function. And what trunc does is take whatever you pass as the x variable and then truncate it. And if you're using trunc POSIX-CT, you can use a units argument for the units of time you want to truncate to. In this case, it would be days. And ultimately, what this will do, if I run this, I can look at my start time, is it truncates off any time on the date and just gives me that date. And when you do that, there is a time associated with this, but you don't see it anymore because it's just 0, 0, 0, 0. And it's actually there in the data in terms of what time of day it is, but the computer doesn't show it to you when you're at midnight or 12 o'clock in the morning, however you choose to think about that. So now we're starting at 12 o'clock in the morning on March 3rd, which is the first day we have data in Montana Standard Time. Now, one trick about this is when you use truncate, it's actually going to change the data type of the time because the way that truncate works is to translate the time from a POSIX-CT into a POSIX-LT. So if I do a class on start time, it's actually going to be a POSIX-LT. And we can talk about that in more detail in other videos, but ultimately POSIX-LT, I can do an unclass, is a way to store time rather than a single number, but as a collection of values that represent the Gregorian date and time. So ultimately, it's based by a list. And if I do an unclass on start time as POSIX-LT, it'll show it to me as that base list. You can see rather than a single number of seconds since an epoch, it gives me a whole bunch of different numbers: seconds of the minute, minutes of the hour, hours of the day, day of the month of the year, etc., etc. And this is a more convenient way to break down time for doing things like truncating to a particular day. So ultimately, we've ended up with a different data type for start time. And this is just one of those things you've got to be careful with R. It's constantly changing data types on you, and you may not recognize it. So if that's the case, we're going to have a POSIX-LT later. That's going to create a problem when we're trying to use time down here to specify the week start and the week end. It can do the math okay, but this particular function is not going to be happy if we use a POSIX LT instead of a POSIX CT. Now, fortunately, it's very, very easy to switch back and forth between the two. We can just use the as function to force this POSIX LT time that comes back from truncate back to a POSIX C time. And that should resolve any problems that we have later on with functions that need a POSIX CT data type to work correctly. Oops, I missed the C there. Nope, sorry, that's the correct trunc POSIX T, and it's as POSIX CT. Okay, so now if I rerun this line of code and I look at class of start time, I can see it's a POSIX CT again. And notice that I have no way of knowing that just by looking at start time. So this is why it's useful to know that class function and that type of function to make sure you know what data structure you're dealing with. Okay, so if we have a start time here and we are starting our week at that start time, we're not running our loop yet, but we should have changed where we're starting our time in our 1 week worth of data in our graph. If I run this, hopefully there are no bugs. Looks like it ran clean. Now, instead of starting on our first data point, we're starting at midnight on that day. If there were ticks for it, March 3rd might be about here. And we've got 7 days of data, 1, and as part of this day, 2, 3, 4, 5, 6, 7. And this will be nicer, I think, in our loop, because if we're starting at midnight, we're always starting on midnight of the day rather than the middle of the day. It'll be easier to look at our photo periods because of the fact that par is generally 0 through the night. Okay, that gives us a chance then to finally create a loop so we can see all of our data instead of just some of it. I just need to have to figure out how to work through this 1 week at a time and change what needs to in order to plot 1 week at a time. Well, the first thing I can do is create my loop. Now in this case, I'm not going to use a for loop because what I want to do here is check a condition each time through the loop and decide whether it's time to finish the loop or not. Right now, I don't really know how many times I need to go through this loop. So another way I can write a loop is use a kind of loop. In this case, I'm going to use what's called the repeat loop in R. And repeat just says repeat the block of code that's in the curly brackets until the code that's within the curly brackets decides it's time to stop looping. And there are special keywords you can use in R within the loop to tell it to stop looping. Now also, while it's looping, I'm going to need a counter that's keeping track of how many times I've been through the loop so far. Before I start the loop, I need to set that counter, and it's going to be 0 the first time through the loop because I haven't been through the loop yet. And I can replace that 0 with a count. Now, the one problem with repeat is you have to be really careful because if I ran this code right now, I would have what's called an infinite loop. It would just keep trying to loop over and over again until it got an error, or it might never come out if there are never any errors. And that's not what we want. We want to make sure this loop stops at some point. So typically, when you do a repeat loop, it's most convenient to check a condition at the end of the loop, down here at the bottom, that decides whether that's the last time through the loop or not. And the way we'll know that in this particular loop is our ending date, our ending time for our week is greater than or equal to some end time for our entire data set. Now we haven't defined that yet, but it's basically going to be the last time in our full data set. If our week end of a given week's plot is greater than that end time where we've run out of data, then that's the last time we want to go through the loop, right? So if that's true, we can break out of the loop. And we can use the break keyword here to specify that. Now, if we're not breaking out of the loop, we need to do something else. And that is increment our counter, because we finished the loop. Therefore, we need to say, well, we finished our loop, so our counter that's keeping track of how many times we've been through the loop needs to be incremented by 1. And then with this if else, we have everything set up that we're ready to either break out of the loop and be done with it and go on to the dev off, or we set our counter to we increment our counter to 1 value higher, or add 1 to it, and we go to our next iteration of the loop. So this should make sure that we don't have an infinite loop. It should make sure that our start time for each week depends on how many times we've been through this loop. And I think that's all we need to run through all of our weeks of data. So if I rerun this chunk, oops, I've got an error. Oh, I've defined end time conceptually, but I never actually defined the variable. So I got an error. Fortunately, I didn't get an infinite loop. It said, I don't know where end time is. So we need to specify end time. Let's just do that up here where we specify start time. And it's pretty straightforward. End time just needs to be the maximum version of this, the last time in our data set. So now we should be able to run this. And now we're getting to the point where it's probably going to take a little bit to run, and we can see if we've got more than one plot. And we do. So we now have several pages of data, and you can see how we're starting on a particular day of the week and plotting 7 days of data for each week. And we have many, many of these plots going all the way through our data set from March through the summer, all the way to our last data point, which was on November 11th. So just a quick review of our chunk now. We've converted our timestamp into a numeric time. We've set up a device, Cairo PDF, so we can write to a PDF file. We've set up our default margins. And with a PDF, every time we call plot new, we'll create a new page in that PDF for a new graph. We have changed the attributes of our time, specifically the time zone attribute, to US Mountain, and that's going to help us with our quality assurance, because it'll make more sense thinking about when PAR is high versus when it's low during the day. We've established a start time and an end time for our entire plot, and that will help us keep control of our loop. We have established a y-min and a y-max for our whole plot, because we want to keep our axes constant, because that helps us keep track of when it's low and high. See how it's low in November, and as you scroll backwards, it'll get higher and higher as you work earlier and earlier in the fall, then into the summer, where ultimately when you get through to June is when it should be at its highest, near the solstice. And then once you get on the other side of around June 20th or 22nd, somewhere in that range, we'll start seeing it go back down again through May into April. And ultimately, our first data points in March are when it's fairly low, though it does get lower in the winter. But we want to have a constant Y scaling on our axis so we can see that, because it helps us make sense of our data and make sure it looks appropriate. Then we can start our loop, where each time through, we're incrementing our week start by how many times we've been through the loop before. And if we multiply that count times the number of seconds in a week, each week start is incrementing by a week every time we go through the loop. Our week end is just going to be 1 week beyond our week start. We are finding indices of the part of the data set that are part of that week, and then we proceed to filter our data by those indices and plot those data for that particular week. Ultimately, at the end of this loop is where we check if we need to break out of the loop if we've reached the last week of data availability. If we don't break out of the loop, we want to increment our counter so that the next time through the loop, it is shown that we have finished another week of data. And then after the loop has finally terminated, we need to turn off our device so it will write the PDF file.